So, as you know, I am a faculty at Princeton, and I'm very fortunate to that my institution makes a lot of resources available to me. So I have a lot of staff. I teach the courses with colleagues. We're not alone in our courses. And we are able to we have a lot of undergrads who are very smart students, and we're able to hire them and pay them. So we have a lot of resources, and I'm very grateful for that. But at the same time, even if you have fewer resources, or no matter how much resources you have, there's always the possibility of misusing those resources or focusing on the wrong things when you're delivering your outputs. So in this first part, I would like to sort of talk to you about the process that we've gone through building codePost. And I sort of want to push back against the two most straightforward arguments that I get when I talk about giving code feedback, which is people tell me, I don't have the time. And if they do have the time, they say, I don't have the resources. And I want to show you that even when I had time and resources, I could do a terrible job. And it took shifting our perspective to deliver good work with the time and the resources that we had. So let's go back in time. I was hired at Princeton in September 2014. I was coming from a postdoc in Vancouver. And in Vancouver, I essentially was a research postdoc, and I needed a little bit of more extra money. And so I applied to teach a course, an intro course. And I only found out maybe a couple of weeks before I got the position that, yes, I got the position. And when I said, well, that's great, could you give me the material, the syllabus and all of that? They said, well, there's a title to the course and that's it. And, if you want to know more, maybe you can talk to somebody who's taught it before, but basically that was it. So all of a sudden, I only had 1 week to get ready, and I had to teach 200 students. And I had maybe 2 TAs, but I had to tell them ahead of time everything that they needed to do, because we had these very strong union contracts, and I didn't know what I was going to ask them, and I didn't know what I was going to do. So I ran that course with 200 students just by the neck of my pants, or I forget what the expression is, but it was a very stressful experience, and it taught me to use automation to get the most out of my labor. I could only be at one place at a time, and I needed to use automation to be able to just get work done and processed for these 200 students. So I was hired by Princeton for the following term, and I thought to myself, now, this is Princeton. This is it's a wealthy institution. It's an advanced institution. What they must be doing must be so much better. And lo and behold, I was parachuted in this situation that I did not think was particularly attractive. So back at the time, we had this weekly programming assignment. All of the assignments were created by Professor Sedgwick and Wayne, who had this really popular textbook, and later this really popular Coursera MOOC. So the assignments were set. I was teaching CS2, not CS1 at the time. There were 130 students, 6 sections, 1 instructor, which was Kevin Wayne, 2 faculty section leaders, which was myself and then my colleague Ananda Gunawardena, 3 grad TAs, 4 or 5 undergrad grading assistants. So all of the material was available, was set, and there was a huge staff. So it was a better situation than what I had in Vancouver. And in addition to that, we had an expansive legacy of auto graders with test results, some of which were exposed to students, some of which that wasn't, that we used both for them to be able to figure out if their submission was right, but also to help pre-treat the grading. And then we would grade out of 40 points. And one feature of this whole system that really stuck around with me is that we never provided students with solution code because we were concerned about plagiarism. So to give you a sense, these are what the submissions looked like. They were printed out. And this is the kind of feedback that I would typically leave on any feedback. So 39 out of 40 and good code. And that was it. So, and as to summarize what was happening, basically, It involved the CS2 grading at Princeton in 2014 involved a lot of paper. So a lot of our time was wasted printing paper. And you can see here an image of the photocopier that I lobbied the department to get so that we could not only print, but also staple things because we had to previously hand staple them. We had to keep track of the physical location of submissions. So when I gave them to graders to grade, I had to keep track of who I was giving this submission to because they might forget it or they might lose it. And I had to be able to say, well, this grader got that submission. And then because it was a paper submission and because students had to come and collect them, most often they wouldn't. So we also had to spend time destroying these old exams or submissions. And then the grading process, it consisted of applying a very meticulous rubric that you can see here that was focused on the deductions. So it wasn't a rubric that was focused on telling students about something. It was a rubric that was focused on making sure that we deduct the right amount of points. So in a sense, the grading was less about helping the student solve their mistakes or helping them grow from what they don't know. And it was about, and I put this in quote, assessing the worth of a student. So saying, this student is a 33, this student is a 40, this is a student is a 25. And the purpose of this was to be able to rank students accurately at the end of the process. So there was no pedagogy, no feedback. They didn't get, as I said, the solution code. And from the point of view of students, what was very difficult, but also from the point of view of graders, is that all of our grading process was spread out in multiple documents. So we had the rubric, we had the test output, we had the grade report, which was how every graders would keep track of the submissions that they graded so that I could audit them. Everything was spread out across many different documents, and it was very hard to keep track of what was actually going on. So to recap, the problems for the students is that they would get no to little feedback, and the auto-grader output seemed very, very laconic, not very expressive to them. The rubric and deductions appeared very arbitrary. And since they were not given any solution code because of our plagiarism concern, there was very little opportunity for students to improve. So say that you are a student who provides a perfect submission, then you get a 40 out of a 40 and you go on your path. But say that you are a student who has failings, so maybe you get a 25 out of 40. So you get the deductions, but you get no information on how to fix the problems that you receive. And in fact, you know, we often put -5, but we didn't say why we put that -5. So they got very little feedback, and the weaker students, the students that were less competent, had no luck, no opportunity to improve. So the problems for instructors is that the bulk of all time was being misused. It was being spent in logistics. So compiling the submissions, printing them, assigning them to graders, tracking submissions as they were being graded, pre-grading the submissions, entering the grades in our LMS system once I got them from graders, and then processing late submissions. There was very limited oversight of graders' work. Once I gave a submission to a grader, I would not really know much about it. And there would be no to limited insight on the student's work. Once a grader had graded the submission, you know, it was near the end of our process, and I never would be able to go through students' submissions to say, oh, this is where most of my students lost points, or this is where most of my students lost points. And then the problem for the graders, and sometimes, you know, when there's only 20 students and you're only one instructor in a course, these were the problems for the instructors themselves, is that the bulk of their time was lost in repetitive work, like flipping through 5 pages of rubrics, or filling out the grading sheets down here, or adding points up and making sure that they didn't make mistakes, or handwriting terse comments. The work was very adversarial. It was about finding everything that's wrong with the student's work, as opposed to holistically providing feedback. And we basically did not have time to read code. It was factory line assembly trying to match problems to deductions. So here I gave you a screenshot and I say, this is the proudest feedback that I personally delivered. And you can see that it's not really much to write home about, like they say. It was basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 words. And because it was 14 words instead of just good code, I was super proud of that. And I thought this was the pinnacle of feedback, because it also provided some feedback to the students on how they can improve. Remember to test across all these dimensions next time. But of course, looking back, that wasn't really great grading work. So to show you some of the evolution of our process, here's a screenshot of codePost in 2014 when I first met James. And this was what he had built on his side. And then here's how codePost looked as we refined it, first internally at Princeton in 2016. And then 2019 is when it actually became a company, and we expanded to a number of other institutions. And you can also see how our process changed to just one room to an amphitheater full of graders that we were able to manage. So to summarize, basically, our resources at Princeton haven't changed, but it's our tooling and our process that have changed. So back in fall 2014, so of course, in fall 2014, I was teaching a CS2 class, and in spring 2020, I was teaching a CS1 class. But that is a very small difference. Like, this is really about the numbers, about how we used our time. And so to recap, in fall 2014, we had 120 students. The labor was 1 instructor, 2 co-lead faculty, section leaders, 3 grad students, 4 to 5 undergrad grading assistants, and a partridge and a pear tree. And most of our time here, as you can see, in red, was mostly on logistics. So I would spend 5 hours running the auto grader, 10 hours printing and stapling, 2 hours dispatching to graders, 3 hours collecting graded work, 2 hours redistributing it. So the bulk of the grading was done over 60 hours, and was basically, given the number of people that we had, was 6 hours per person. So in total, we spent 82 hours, and we spent 40 minutes per student, but very little of that time was spent actually grading students. The output was a grade and maybe a handful of words, and most of the time was spent moving, shuffling paper around, and looking at the rubric. So in spring 2020, we have 1 lead faculty coordinator that's managing the grading, and 30 to 50 undergrad grading assistants. So there are other instructors that take care of other aspects of the course, but here I'm telling you about the grading part of the course and who's involved in the grading. So with just 1 lead faculty coordinator, that's me, and 30 to 50 undergraduate grading assistants, this is how we spend our time. So we spend the same amount of time, 30 to 70 hours overall on grading in the course, because these are undergrads. They cost less to the university as grad students or faculty people grading work. But we're able to spend more time grading. So each person is grading just 1 or 2 hours, but we're able to spend a lot more time actually looking at the submission. And so the time per student is 6 to 7 minutes, but that time is spent providing an assignment targeted explanations and custom feedback that is focused on the students and not focused on deductions. At this point, since I've talked for a lot, I'm just going to check to see if there are any questions. Remember, if you have any questions, that you can go on slide 2. I do not see questions at this time, but I will check later.
Can we ask a verbal question?
Yes, absolutely.
Yeah, so how many students is each undergraduate grading assistant grading? About 10 or 5?
Yeah, so as you can see, every grading assistant grades about between 5 to 10, and that's really an average. So I have some graders who are very efficient and who might grade 15 to 20 submissions. And then I have graders who are less efficient and who might grade only 1 to 2 submissions or 3. In practice, that has to do there's many different reasons why that might be the case. So for instance, the grader who's grading a lot of submissions might be grading a lot of submissions, all of which are perfect. So therefore, the feedback that they're giving is not about something having failed, it's about how to write better code. So For instance, when you have constants that you're hard coding in your code, that won't affect the correctness of the code, but it might be something that you might say from a point of view of style, you might do differently. So providing that feedback is a lot easier, and you might be able to do a lot more submissions, whereas the grader who's grading only 2 or 3 submissions might be grading submissions that are failing multiple tests and where you have to actually rewrite part of the code for the students. But at the end of the day, what's really nice is that when you have 50 undergraduate graders, a lot of persons working at the same time, if one gets stuck, all the other ones can process the other work at the same time. So you're making a lot of progress. Does that answer your question?
Yeah, so I guess it'd be really important to synchronize, or the training to keep everyone consistent would be more difficult, I would imagine, with that many graders.
What we found with codePost is that the consistency is enforced by the tool that we're going to call the rubric. So the fact that you have consistency across the graders is because codePost mostly allows them to provide feedback that is from a palette of rubrics that I have set as an instructor. And that's where the consistency comes from. Does that make sense? Are there any other questions? Okay. Right now, this is a big overview, but as we talk about the concepts of codePost and we show you screenshots, everything I'm talking about will become clearer. So speaking of a screenshot, so this is a screenshot of a submission as provided by students in my course. And by the way, when I say my course, please keep in mind that I work with a team of really talented instructors. I handle the grading completely, but I'm able to do so because they're handling everything and doing like really a great job with everything else. There's no I in team, as they say. So here is a screenshot of the kind of feedback that a student in this course could expect. So you can see this is the student's code. Here are 3 comments, and you can see 2 types of comments here. One, these 2 here, line 8 and line 17 are rubric comments, and you can tell that they're rubric comments because you have this line here. And this part, and I'll come about it multiple times, this part is written by me and is reused multiple times on every submission that applies this comment. This here doesn't have that line here. It's a custom comment. So this is a custom comment left by the grader that is part of their own sensibility. So it's subjective comment left by the grader. And here again is another rubric comment. You can see that it comes from the rubric because it has this line. Here you can see all of the files in the submission that I can toggle through. These are the results of the test. So I can click on any one of these to see more details on the test. As you can see, all the grading in our course is anonymized completely. And this is the student's code. The student can then provide feedback on the rubric, not on the graders. As you can see, they don't have a thumbs up, thumbs down for the custom comment from the graders. And this information of thumbs up, thumbs down gives me information on whether my explanations and the focus that we have is useful to the students' improvement. Are there any questions here?
Jeremy, could you make the font a little bigger? It's very hard to read.
No, actually, sorry. This is a screenshot, so I can't change the size of it. But in the second part of this workshop, we're going to be working with codePost, and we'll be able to make the size much larger. Here, this is just to give you an overview of what this looks like.
Okay, thank you.
But I'm really sorry when. And I
mean, you can. Oh, it's screenshot. Sorry. Yep, you're right. I was going to suggest hitting the magnifying buttons in the top right, but I realized that will not be effective.
Yeah. Oh, and I stopped sharing accidentally. Sorry. Okay. So here, if I clicked, I was telling you that I could click on the test and then see details. So here, these are the details in the test. So again, for every test, we also have an explanation because we believe that if you can write something once and it will be used over and over and over again, then why not be as detailed as you can? You know, explanations make sure that everybody's on the same page. And these explanations are helpful for the graders to understand how to grade something when a test is failing, but they're also useful for the students to be able to debug their own programs and to be autonomous in this process. Okay, so to summarize, I like to think of codePost and this process, I like to think of it as a 21st century code grading toolbox. And our main weapon is to, all of this time that I was wasting before is to try to eliminate that. So first, eliminate all the manual transfers of operations. So when the students submit their submissions, we have to upload them to a server, we have to run an auto grader, we have to transfer them to a printer, then we have to transfer the printed work to the graders, the work from the graders back to the students, and then the grades from those submissions to the LMS. So we want to eliminate all of those things and automate as much of that work as possible. The second ingredient is an auto grader that tries to ensure first and foremost that student code compiles, because if student code doesn't compile, then we have grading the code is a very different work. Because compiling gives you a lower bound from which to discuss, but if you don't have that lower bound, then feedback can go in many different directions. And then the auto grader helps student eliminate obvious problems, and it helps the weaker student makes an iteration of progress. Whereas if they only got feedback from your grading, then they would only be able to have you grade a very bad submission. By giving them the auto grader and letting them iterate, it helps them improve their submission before you give them a human feedback. And then there's a trade-off between the time to write a test and the usefulness of a test. You don't want to write 1,000 tests. Of course, you could be checking everything, but you want to balance how much time you put into writing tests. The second ingredient is the third ingredient is the rubric. So the rubric provides directions to human graders. I'm an expert at grading. I'm an expert at teaching, and I've acquired that through 15 years of teaching. My graders are undergraduates who just took the course, and they do not have all of that background of what to give feedback on and how to give feedback. So I can share my expertise through the rubric, and that's what helps ensure the consistency of grading. The explanations are instructor-authored paragraphs shown to students, and they provide the bulk of the quantitative feedback that is received. These explanations, they try to make it so that if the student reads that explanations and takes it to heart, they should be able to have all the information they need not to make the same mistake again. And then the custom comments, or the customization of the comments, they're individualized comments left by graders, which both help reward students, help address individual code problems, because graders will always be able to provide feedback on things that we can't anticipate. So sometimes some students make a mistake that nobody else will make, and the grader is empowered to provide feedback on that through the custom comments. So would you rather be doing this on the left, which is how grading was in 2014? Or would you rather be writing these comments, which are examples of explanations that I've provided my students, which is basically the point of this whole workshop. So let me take a look at my questions, or if you have any questions, please feel free to ask them out loud. So the next step, James is now going to be telling you what is the code review, what is code quality, why is auto grading alone not sufficient, who does code review and why is it essential, and talk about strategies for scaling code review that will come afterwards. So based on the survey, and I'll double check that if you've gotten some answers in while we were doing this workshop, based on the answers that we've gotten for you so far, it sounds like most of you are in the scenario where you are an instructor alone with a class with maybe 20 to 40 students. And so we're going to focus our strategies on that scenario. The tool is codePost, and our strategies are both useful in an instructor alone scenario, but they're also useful in an instructor with TA scenario. But we won't be talking about that. However, Some version of this workshop is recorded, or we are always available by email. So if ever you want more detail on the management of TA part of this, don't hesitate to reach out. And then once we're finished with this presentation, where we have 40 minutes to 1 hour of live exercise for all of us to be doing together that will be run by James. So I have a question on Slido. What types of reports are available for aggregate reports assessment? That's a very good question. So you will see that codePost is really great at mining all of the data that you're collecting. And I'll show screenshots, but to give you an overview, you can get aggregate reports on the performance of students. You can get aggregate reports on the individual comments that are left by graders. And you can get, the most powerful tool to get aggregate reports is the rubric, because then you get to see deduction by deduction, how many students got that deduction, whether they upvoted, how many upvoted, how many downvoted. And you get this really granular data that helps you improve the feedback that you give to students. And we'll show screenshots of that. And that person who has that question, please at the end of the talk, please make sure to let us know if we've sufficiently answered that question for you. But if not, the sky's the limit really in terms of what you can take from the data, because we have an API. Okay, and so if there are no more questions, I'm going to now hand it over to James. James, just a quick question. I assume you want to share your own screen, right? So I'm going to stop sharing the mic. Yeah.
Okay. All systems go? Great. Okay, so thanks for having me, everyone. I thought we would start with a quick warm up. So this is an example I love, a code example, to illustrate why checking for correctness only when evaluating student work might be suboptimal from a pedagogical perspective. So here on the left, hopefully this is big enough for you all to see. Is that the case? This code on the left, sort of? Yeah, okay, great. So it's just a single Java method called day of year. It takes in a month, a day of the month, and a year, and then returns the day of the month corresponding to those arguments. So this code is intended to be technically correct, but since we have such a small group, maybe we can just point out anything about this code that strikes you as not effective.
Well, it's certainly not written for efficiency.
So a lot of conditionals, that's right.
It doesn't recognize leap year versus non-leap year.
That is very, very true. That's almost, it's probably the least correct part of the code.
I want to check all those numbers, make sure that they're adding the right numbers into the right way.
Really hard to audit.
Yeah.
I thought an interesting answer when we presented this last year at 60, someone pointed out that this code doesn't handle January, which I initially agreed with, but in fact, and that's just because there's no conditional statement corresponding to month equals 1, but if you actually trace through the code, it turns out that it's correct, because if month equals 1, you just skip all the if-else statements.
And return day of month.
That's a situation where it's technically correct, but it's really hard to assess the correctness just by looking at it, because it's set up in a way that makes it really difficult to assess. A lot of repetition, no validation of arguments, doesn't make saved copies of arguments. It manipulates day of month directly. So a lot of things wrong with this code that, if it showed up in our code base, I know would get a lot of scrutiny. So second question here would be, so we've identified a lot of issues with this code, even though besides the leap year point, which is a very good point, it is technically correct. What are some tests you could write to detect these problems in an automated way without actually reading the code?
Well, you could grep the source file for like the number of plus operators or the number of else if, with regular expressions or something. I mean, essentially what a human would do looking at it, I guess.
Right. Yeah, I think that's probably the most reasonable automated approach. The point of this exercise is to this is of course somewhat of a canned example, but it's to show you that this is a piece of code technically correct, highly suboptimal from a design perspective, wouldn't pass muster in industry. It's very difficult to assess in an automated way by writing tests alone. And so this is the kind of the motivating example of why codePost exists, to make it possible to make the automated correctness checking fast and easy, so that humans can do the work that humans are best at doing, which is identifying, or better at doing, which is identifying these types of suboptimal features of student code and providing ways for students to improve in these areas. So just a bit of a preamble on why code review. So although code review isn't, at least certainly when I was an undergraduate, wasn't ubiquitous in higher ed, our mission in codePost is to make it more ubiquitous. Code review is ubiquitous in industry. Any company worth their salt spends a significant amount of time reviewing code, and there's a business reason for that. Code review helps ensure collectively what is dubbed code hygiene. Code that's reviewed is more maintainable. Human readable code is easier to check for errors, easier to reason about, easier to onboard someone to a code base. So anyone who works in industry knows that correct code doesn't necessarily equal good production code. But there's also a a technical benefit to code review in the workplace, which is it facilitates a discussion around correctness issues that might not otherwise take place if the sole goal of someone writing code for a production code base is correctness. And so just to bring this to life, at codePost, we spent a lot of time building our product, obviously. And we did a exercise where we tracked how much time we spent writing code versus reviewing code for a month. And it turned out about a quarter of the time we spent working on the product was dedicated to code review. Now, maybe we're biased, but I think if you did a similar survey in industry, you'd probably find pretty similar results. And then the last point here is, there are some skills that we really focus on in higher ed, but that are really important in industry. For example, as a student writing an assignment, once you might work on that assignment really intensely for a week, but in most courses, that assignment is going to be jettisoned into the ether after it's graded. But of course, in industry, that's never the case. This operating assumption always has to be that someone other than the original author will maintain the code you write. Another skill that is really useful in industry is the ability to write specific actionable comments about other people's code. Receiving those comments as an undergrad is a really helpful kind of baptism into that practice. And of course, this is not the skill that's more generally applicable than just in a software engineering context, but being able to react constructively instead of defensively to other people making suggestions about your code, even if your code is correct, is a super valuable skill and really hard to be kind of innately good at without going through the practice of having your code reviewed and marked up by a human. At codePost, we've worked with a lot of instructors, and so we've come up with kind of three failure modes, or three categories of code that are particularly hard to review. The first, which Jérémie alluded to, is when code doesn't compile or contains syntax errors if it's not compiled. And of course, the issue with this category is that it's impossible to test in an automated way. So one syntax error, boom, you're stuck kind of fixing it, and we actually have a tool in codePost that will help you fix it if that's unfortunately the case. But really hard to automate correctness checking if the student code doesn't compile. It can involve manual traceback. You know, it's a real pain in the butt. The second category is code that doesn't adhere to a specified API. So maybe a student, you know, moves around the argument order in a homework assignment or uses different function names. Most test suites are written assuming a specific API. And so what that means is you, for a student whose code doesn't adhere to the specified API, failed tests might not expose specific bugs. And when you're manually reviewing code, this is an interesting piece of feedback or interesting phenomenon we've heard from a lot of instructors is that, you know, when you're grading multiple, and I'm sure, you know, everyone in this room has had this experience, when you're grading multiple submissions that have kind of a similar structure, you can get in the flow of expecting certain methods to show up in certain places. And when a student deviates from that structure, it can take substantially longer to kind of grok their code, build up a mental model of it so that you can assess it. And then of course, I'm sure everyone has experienced code that, you know, compiles, adheres to a specified API, but it contains wacky style, you know, really long lines, no comments, bad indentation, which just makes it really hard to read. We like to call this type of code wingdings code because it's as if someone, you know, submitted an essay written in wingdings font. So solutions. So, and we'll talk about, once we get to the exercise portion, how to actually make this happen in codePost specifically, but this is just a kind of generic set of recommendations to avoid falling into it, to make it so that your student submissions don't fall into those three categories. So the goal here is to create a quick feedback loop for students to incentivize them to submit code that is easy to review, that doesn't fall into those three categories. The way to do that is to allow them to submit code and receive immediate feedback if the code falls in one of those categories. So it doesn't compile, has syntax errors, doesn't adhere to a specified API. And so in codePost, what that looks like is taking, writing some tests, putting them into a test category, and exposing those tests to students at the point of submission. So that means if it's, you know, my assignment's due at 11:59 p.m., it's 10 p.m., I submit code that doesn't compile, I'm going to see that immediately. It's going to tell me I failed this, you know, first test, and that if I want to pass the assignment, I need to submit code that compiles. And so that's going to nudge me to obviously submit code that compiles. You can gamify this a little bit by calling this something like, you know, level 1 requirements, or something to indicate that they represent, you know, the absolute must-haves in a submission. And you can attach point values to further incentivize this behavior. You know, we've seen some people go as far as to say, look, if your code doesn't pass these tests, these level 1 requirements, which are again the most basic, you don't get any points for the assignment. And of course, you can tune that according to your circumstance. I'll pause there before handing it back to Jérémie.
Thank you very much, James.
So I have a quick question. So if the student's code is not compiled, so the student won't get any points. Is that right?
That's the more extreme version that we've seen. I mean, it's definitely effective in incentivizing students to submit code that compiles. And our experience has been that if you make that a level 1 requirement, students tend to do a pretty good job of working towards that goal. They may submit code that includes, you know, that has, you know, more correctness errors, but at least those correctness errors are identifiable by your tests.
And also, when I think it's important to keep in mind that we make an auto grader, some sort of auto grader available to students. And so what that means is that if the code doesn't compile when they submit it to us, it means they've given up, because they have the auto grader that will tell them, well, this code that you just submitted doesn't compile. There's a problem here. You need to fix it. And the point is that as long as they are iterating, like the auto grader doesn't cost anybody's time. You build it once and then any student can interact with it. So part of what we've been doing and what we recommend, what a lot of people do, is to encourage the student to engage with the auto grader until they just can't improve what they have anymore. And that's when they give it as a submission to somebody else. And we're very fortunate in our experience, I don't think I've ever seen a submission that doesn't compile for assignments, but it's because there's this gatekeeper, which is the auto grader, that says, well, this doesn't work. Why submit it? It's not going to give you any points anyway. And it incentivizes students to work just a little bit harder to make whatever they submit compilable.
Makes sense. Thank you.
Are there any other questions? Okay. If you just quick check, are the slides showing up well? Thank you. Okay, so personalized feedback workflow. So now I'm gonna sort of like give you, in the first part, I told you what we don't want to do. Then James told you what we're trying to do. And so now we're gonna give you a closer overview of what this looks like with codePost. So in this section, we will show you a concrete and efficient personal feedback workflow. So what we're going to be focusing on, as I mentioned, and I just double checked the survey again, we're going to be focusing on techniques for instructors alone that, of course, work when you are working in a group. And if there are future questions, as I said, we can take them offline on the quality check. All of my examples are based on my own workflow in Princeton CS1 course, where typically on a given term, I would handle 300 submissions a week. I'm able to do so with 30 to 70 undergraduate graders, each spending 1 to 3 hours. And the main advantage of this parallelization is speed, but this could be done with a smaller number of full-time TAs. So for instance, if you don't have 30 to 70 undergraduates, but you only have, say, 1 grad student or 2 grad students, the amount of work that they can provide might be larger than what these undergraduates can provide. So we've mentioned this before, but now that we're going to be going into the devil is the detail, and it's really important that you understand that in codePost there are 2 complementary notions of comments. There are the rubric comments, and the rubric comments belong to a rubric. I create them, and then they're instantiated by the graders, but everything about these comments is controlled centrally and retroactively by the instructor. So the instructor gets to choose the grader description, so that's how graders will see it. They get to control the student explanation, that's what students see. And the instructors get to control the point delta, whether that rubric comment removes points or adds points to the submission when it's applied. And they also contain a small part, which we call the customization of the comment, that is left by the grader. And then distinct from rubric comments, we also have custom comments, which I've already shown to you. And these are discretionary comments left by graders that come from the subjective appreciation of the grader. So this is not something that I've said they have to put from the rubric, but it's something that they want to provide as they're providing feedback, just like an English professor might provide some ad hoc feedback on an essay. And these notions are important because they're tied to how we do quality control and scale efficiency. So to be very, very specific, here's an example of a rubric comment. And I'm talking a little bit about the terms, the notions that we use to talk about these things. So this is a rubric comment. It's the same rubric comment, but on the left, you are seeing what the grader typically sees. And on the right, you are seeing what the student will see. And it's important that there's a distinction. The reason why is that on the left, you see that the grader sees the grader caption, the grader facing caption. And this greater caption is meant to be very short, not explanatory, but very short so that the grader can easily distinguish between all the rubric comment and can easily find the rubric comment that they want to apply. On the other hand, on the right, you see the student explanation. And that is very detailed because it's the opposite. The student who didn't get this is going to need as much detail as possible to be able to understand what they got wrong. We can't just say, you got this wrong. We have to explain what they got wrong and how they can get it right. The second element of the rubric comment is the customization. So the customization appears below the section with the line, and the customization is written by the grader to match the specific scenario of the student. So the caption and the explanations are written once by the instructor, by me, and the customization are written by the grader for each time that they apply this comment. And you can see the interplay between the explanation and the customization here. So here, as you can see on the very left of the screen, and I'm going to annotate it, this is the student's code here that you're seeing a smidgen of. And you can see that the students use the word index, and that's what is being commented on. And so here we're saying, instead of keeping track of an index, you can convert from 2D coordinates to 1D coordinates using this formula. But this comment doesn't explain, because it's generic, it's meant to be that pertinent for every student. It doesn't actually address how the student themselves would have used this formula. So that's the work of the grader. In the customization, they say, well, you have this array feature vector that you were accessing using this index variable. Now you're going to index it using this formula. So the job of the grader is to provide the last mile of how to say, this is this generic explanation, and here is how you can apply it directly to your own code. And so the job of the grader is two things. It's identifying which rubric comments to apply, and then providing the connection between the generic advice of the rubric comment explanation and the actual code of the student. Are there any questions on that? Because that's really like one of the main ways that we are able to scale and have me write an explanation that is very detailed, that is applied to a whole bunch of students, but to make it relevant to each of the students.
Yeah, I like how there's both a grader caption and a student caption so that it's more compact for the graders. When graders make specific comments that are not the rubric comments, do those also have points attached to them? Are they able to change the score arbitrarily when they're grading, I guess is what I'm asking?
Yes, yes. When the graders leave custom comments, they can control everything about the custom comment, including the point delta. If you do not trust your assistants with doing that, you can also restrict their ability to leave custom comments, and you can, for instance, turn off their ability to leave custom comments and say, you can only apply comments from the rubric. Does that answer your question, Chris?
Yeah, thank you.
Thank you for that.
I was thinking about what you said on the previous slide about controlling for scale and the other, I forgot what the other thing was, but.
Quality check, the two things, scale and quality check.
Yes, yes. So, and I guess that's a trade-off of how in sync everyone is and how much training the graders have. And just for reference, the most graders I've ever had was 5, which seems like a lot at a lot of our institutions. I typically have 0, so it's a different scenario.
But how much time would they give you, like, for given a piece of assessment?
Oh, I don't know. I think they would probably spend a few hours each on the workload that I, on the weekly, probably several hours a week on our weekly grading workflow. So. Yeah,
so it's really important to keep in mind that my graders only spend 1 hour. Like we've made a choice, instead of hiring 10 graders and giving them a lot of work, or 5 graders and giving them a lot of work, we've made a choice to hire as many as possible. Both because training graders is, I believe, to be useful, and also because it provides randomization. So you're sure that every submission is graded, pretty decently overall.
It sounds like it's also good for the students' professional development as well, right? That gives more students opportunities to be involved in the department.
Yes, exactly. Exactly.
I have a question.
Yep.
So let's say you had this rubric and student grader apply it and finish grading. But then maybe there's this tiny piece, it's not right. So later on you caught that. So do you restart the whole thing again, or is it possible to apply back to whatever is graded and change it from there? Universal.
So what do you mean by something went bad? Do you mean
maybe one little rubric item is actually incorrect?
Excellent question. Excellent question. So as I said here, retroactively, what I mean by that is that you can edit the rubric after grading is done. And in fact, I do it all the time, which is that a good example is that if you have a deduction and you then notice that everybody in the class is making that mistake, well, then maybe that deduction, you might take it off, because if everybody's making that mistake, maybe you didn't teach the thing correctly and it's not fair to be deducting students. So after everything has been graded, you can go into the rubric editor and change how much you want to deduct. You can also change the explanation. We've made it so that we want to learn from every time you grade, you learn information. And then when you learn information, maybe you want to change things. And we make that very easy. So you can change everything after the fact. Does that answer your question, Wen?
Okay, thank you.
Thank you for the question. So now let's dive into an individual scenario. And let's say, I'll give you an example. You're grading an exam or a new assignment and no rubrics exists. So that's not my situation at Princeton, where when I parachuted into the course, there was already a rubric. But here, let's pretend that no rubric exists and we have to build it from scratch. This is very close to the situation you would be in if you're a single instructor and you're creating a new assignment and you don't know how you're going to be grading ahead of time. So you're starting from scratch. So how would you go about that? Well, the broad outline of how this might work is you would have 3 steps. So tag first, explain later. In step 1, you are going to grade submissions and create the rubric as you go along using the inline collaborative rubric feature. And you can use it alone or with 1 or 2 trusted TAs if you have them at your disposal, but you can work together on the same rubric. Once you have tagged your submissions, once you've created the rubric, you can explore your data set and use the combined examples to help you write explanation for each rubric item. And then after step 3, if you left any custom comments in your submissions, you may audit them to see if you can merge some to become rubric comments. So step 1. Here's what the step 1 looks like. So originally, as you can see, the rubric is empty. And you're grading your first submission. So as you go along, you can either add custom comments if you think that a comment is unique. So you're maybe providing some encouragement to a student, or you're commenting on something you don't expect to ever see again. Or if you see a problem that you expect might recur in your class, you're going to create a rubric comment as described here. So this will help build the rubric for your assignment and keep every submission linked to the corresponding rubric item if, like, when suggested, you want to post correct the grading in any way. So here's an example of how that would process. Here in the rubric, you might create first a category. So I'm going to draw here. So you would create a category here that I'm going to call style. So then that category appears, and then you're going to click add comment to add a specific comment in the category. So here we're going to tackle the problem of a hard-coded constant. So as we discussed, we don't like to hard-code constants. If you're going to use 255 in your submission, it would be better to create a constant that you're going to call max RGB, set it to 255, and then use max RGB everywhere that you would have used the number 255. And that's good because if ever the max changes to say 512, you only have to change it in one location. And the second reason that it's better is that, as we saw in the example that James had you in with 31, 28, and all of that, if you have a lot of numbers, anybody that reads your code that might have to grade it or edit it or maintain it or expand it, it's going to be very hard to know what these numbers are, whether they can be changed, whether they're important. But if you give them a name, then all of a sudden it makes clear what the name of that, what the purpose of that number is. So this is a really important deduction, a really important comment to put to students. So I expect that it's going to be one that I'm going to be giving to a lot of students. So I add comment, I call it hard-coded constant. That's going to be the caption that graders are going to see. I'm not going to put a deduction. I don't really like deductions, just between you and me. And then here's what it's going to look like when I apply it on the submission. So here you can see that there's a line here that indicates that it's a rubric comment. There's a category here, style, and then there's the grader caption, hard-coded content. And then below, I have a box to provide my customization. And my customization is that the rubric comment tells generically to students that they shouldn't hard-code constants. And here, I'm going to specifically say, the problem here is your 255, and I'm going to specifically suggest max RGB could be a name for that constant that is appropriate. Okay, are there any questions on this? Will the rubric have different comments from which to select on a single item? So I am not sure I exactly understand this question, so let me tell you what I understand of it. Yes, the rubric is going to contain different items. And yes, you can apply any of these items to a given comment, but no. So here I've underlined 255, and it means that I can apply one rubric comment to this one piece that I'm underlining. If I wanted to apply a second rubric comment, I would have to highlight some other portion so that I can leave a second comment. Every comment, there's one specific rubric comment and one specific customization at most. I hope that answers your question, but please don't hesitate to follow up now or post a different question in Saidu if it doesn't. Okay, so let me clear these drawings. So now step 2. Now, once you have added a whole bunch of comments, you're now going to go in the rubric editor that I sort of mentioned to Wen earlier. So here in this comment text, this is the text that you will have entered previously, like hard-coded constant, the grader captions. This is what the graders would see. Now, what I think that I would do now is that once you've graded, you get to see, as you can see here, how many times each of these were applied. And if you wanted, you could click on these numbers to see and visit the individual submissions. But what I would suggest we do now is that we click on explanation here, which will let me edit and then preview a very long explanation. So what I do typically is that once the grading is done, I click on this little button here, 35, to explore where that comment has been applied. And I say, oh, this is what these mistakes look like for the students. And then I can write an explanation that targets that misunderstanding. And so then I can write this explanation. And so the students, instead of getting the very terse grader caption, they're going to see the explanation that I just wrote using their code as a basis. The other thing that we can do is that if we find that some of these comments are similar, we can merge them so that they get the same explanation and the same deduction and the same everything. For me personally, this is my favorite part of the grading process because I can speak directly to the student. Like what's nice, I find in my job as an instructor is when you don't have to cut corners, when you're maybe in an office hours and you're sitting with the students and you can actually try to get at the bottom of what they don't understand. Well, this is sort of the introverted offline version of that process where now I get to see what all the students have done, and I can see it, and I can dive into it, and I can slice and dice it, and I can write an explanation that tries to encapsulate everything that I've seen. Oh, crap. I am sorry. I stopped sharing instead of removing the annotations. Okay, and then the last thing that I will talk about is auditing. So here, the rubric editor will let you take a look at all the times that the rubric comment has been applied. But as we said, graders can also leave custom comments. And so how are you going to audit that? How are you going to make sure that there isn't anything silly that's been provided? So now we have the custom comment explorer, and this provides you, and it lets you search through all of the custom comments that graders have provided. And so sometimes this allows you to make sure that the graders are professional, but it also maybe provides you the opportunity to group all of these custom comments and create a rubric comment. So here's a very specific example. I was auditing the custom comments that my graders left, and I saw that a lot of them used the word camel case, and looking at the explanations, they were sort of explaining to students how to name their variables. So what I could do is that instead of just letting it all be custom comments, I said, this is a great idea for a rubric comment. So I was able to select all of those comments using the checkbox, and I was able to apply a rubric and create a new rubric comment called camel cases that you can see on the left, and then convert all of these custom comments to that rubric comment so that I can track it and I can have one same explanation for everyone. So this allows us to be consistent and allows us to be efficient. And so I'm not going to go into a lot of details, but nowadays we've built an auditing tool that plugs on top of codePost. And so what I asked my graders to do is to audit each other. So the graders now, and this is part of their learning process because I try to train the graders, I have every grader take a look at 2 submissions from another grader and then go through a list of criteria to help us identify good and bad patterns of behavior. So this is an example of that process. And this auditing process is very easy to get started in your course. Okay, so let me know if you have any questions, and if you don't have any questions, we will walk through a live exercise with James Evans. So let me check Saidu. Are there any questions from that you want to ask live maybe?
I have another one. So I assume your system can be made FERPA compliant, right? Because certainly you have undergraduate grader and you don't want the student know their name, so then perhaps you get a favorism or something like that. But it seems that your system can be made easily.
So the system is already FERPA compliant. So first of all, FERPA has an exception. It's called the vendor exception and the employer exception, which means that essentially anybody that you pay in the context of teaching is an employee and can be made available confidential information. So at Princeton, I don't know how you handle TAs or whatever, but anybody that you hire to work in the course can have the same access as you. If you decide not to give that person access, institutions have different requirements that supersede FERPA. So if you decide that you don't want your TAs to know about your students, or that you're hiring undergrads and you're not comfortable with them knowing about the identity, that's very well, it's not FERPA, it's very possible. Now, codePost takes a very maximalist approach. We really don't like privacy invasions. So the whole process is anonymous. Graders typically don't get to see each other. They don't, I mean, they know who they are, but they don't know who's grading what. They don't know who they're grading. As you can see from screenshots, or as you'll be able to see from screenshots, all the students' identity is anonymized. So even though we should be able to make identity of students available to graders, we don't. And we find that that just makes a lot of questions just a lot easier. Since grading is completely anonymous, it removes the possibility of having to deal with conflicts, because even when graders don't have to grade anonymously, you still have to account for conflicts of interest. So for instance, what if they're grading a friend or a sibling or something like that? Even if it's not in the context of FERPA, you have to handle these things. So by making everything anonymous, you're addressing that, and also more delicate questions like student bias. In fact, one thing that I don't say all the time, but that I will confess to you, is that when I was first grading, it was a slog. And I remember a really bad afternoon where 3 or 4, all the undergrads were called in sick because it was their midterms and they didn't want to come and help us. And 2 of my grad students called in sick. So it was me, my faculty colleague Ananda, and another grad student who had showed up, and we were trying to get through 130 submissions in one Friday afternoon, and it was terrible, and we were just bad, grading them bad. And at one point, I was like, oh, this is going to be a terrible submission, and I was thinking to myself, now wait a minute, stop. Why do you think this is going to be a terrible submission? What information led you to believe this was going to be a terrible submission? And I saw that the only information I'd seen was that the student was a female, and I'd thought, oh, this is going to be a weaker submission just because the student is a female. And I was horrified that I'd made that connection. And I made that connection because I was exhausted. It was the end of an exhausting week. And I caught myself, but I thought to myself, if you make these cognitive biases, these bias shortcuts, what can you think of the grad students? What can you think of the undergrads that have less professional experience in dealing with these biases? And so that's why we came to the decision very soon to build our product in a way that we can make everything anonymous, just to make it so that there's no questions about these biases.
That's great, thank you.
Okay, and if there are no other questions, I'm going to now hand it over to James.
Thank you, Jérémie. Would it be, maybe we can take a 3-minute break before we embark upon the live exercise. So maybe meet back in 3 minutes. And then just to underscore the FERPA during the break, I just posted our terms of service. CodePost is used in I think hundreds of universities at this point, and we've never had an issue with FERPA. Our terms specify basically that we operate under the same way that a tool like Google Docs or Gmail operates. See everyone.
3 minutes. So let's come back at 52. Thanks, Chris, by the way, for all your questions.
Has anyone here used codePost before?
No, I can't believe I haven't heard about it till today. I'm glad I came to this tutorial.
So are we.
I hate to bring up an elephant in the room. I'm just curious if you have a document somewhere that you compare yourself to other alternatives or to competitors to sort of explain differences or strengths or.
That's a good question. We don't have that document. But I mean, I'm happy to talk about differences if you're, focused on specific.
I'm just curious. I mean, I've been at, so I mean, I don't want to monopolize the meeting, but
no.
We use internally, we're using Autolab, which is the auto grader from CMU. But I mean, we have our own instance internally and sort of make it do what we want it to do. And then in addition to that, a lot of us use Gradescope. And so there's like the pain of multiple, tools, right? And Canvas is our LMS. And so that's like where everything ends up at the end of the day. And so.
Totally.
So I will say one of the main differences between us and in Gradescope is that we really tried to do, like they started from scanned paper. So they have all these images and they're doing this image processing essentially. Right. We really wanted to focus on everything you can do that with code. Code is this very specific kind of text that actually, has a life of its own. And we want to make sure to benefit that, but we can talk more later. Yeah. The only thing I will say is, and you'll like the last part of our talk, which is we have an API because we've lived through all of the problems with integrating different tools that don't want to integrate with each other.
Alrighty, let's do it. So I'm going to share a few things in the chat. Well, one thing, which is a little walkthrough of this exercise so everyone can follow along. And what I'll do is I'll share my screen and I'll have the document open as well as codePost. So we can, I'll show on the screen step by step, but yeah, please follow along on your own. Alrighty. So we've got basically through this exercise, we'll be walking through how codePost works and some of the cooler features by grading a sample assignment. But before we get into what that assignment is, let's do part one, which is getting you set up with the basics. So if everyone could go to codePost, I'll share my screen. Our URL is codepost.io. Click this big green sign up button on the top right. Create course, and then you can put in your institutional email, select your organization from this list, or click this and enter it if it doesn't exist. And that's all you need to do to get set up with an account. I'll give everyone a few minutes to do that. Let me know if there's any questions. We're a small enough group that we can debug live. Hopefully no bugs with this part though. On the homepage, you can see some other schools that use codePost. And to the question about how we compare to other tools, I think the best place to get a read for that is this testimonials page. Okay. Show of hands, who's signed up successfully? Any issues? No? All right. let's keep going. So I'm gonna momentarily stop sharing while I log in. Okay. Alrighty, so now I'm logged in, and I'll just quickly orient you to what you're seeing. So when you log in as an instructor, there you will enter what we call the admin console. And so an admin, you can think of as you're all admins. So you're course leaders, anyone who's going to be in charge of controlling a roster, in charge of creating a rubric, in charge of creating student work, or an admin, and you'll do that work from the admin console. So first step, we're going to create a course. So your workflow will look a little different than mine because you're signing up for the first time, but I'll show you how to do it. So create a course. You'll see this little modal here, and then you can call it whatever you want. So let's do CS 101, enter the name, and then period, synonym for term, you can do fall 2021. You can see if you were creating a course, a second version of a course, you could clone that existing version, but we'll just start from scratch. Okay, easy enough. Next, we're gonna add a roster. So to do that, I'll navigate over here to the roster section. You can see I can add an admin, another admin if I want, because right now I'm the only one. I could add graders. I'm the only grader too. But now let's go ahead and add some students. So we use email as the primary key for all users. So you can just go ahead and click add students by email. And for the purposes of this demo, go ahead and add these students specifically. So I'll copy from the doc and paste. Now I can click review roster changes. Just a note here, if you have a big roster, don't want to enter them manually, you could have uploaded a .txt file, new line separated or comma separated, and that would work too. So now it's just telling me what's happened, what the changes are going to be. This is useful if, like, week 1 of your course, you want to upload a new roster, another text file. It'll just show you, who's dropped, who's been added, etc. And I'll hit confirm. There are my students. So far, so good. Cool.
Is everybody able to follow along?
So now we're on step 3 in the document. All right, I'm gonna move forward because right now we're just laying the groundwork. This is really boring. We'll get to the interesting stuff in a second. So we're gonna go ahead now and create an assignment. So up here, assignments, then overview. I'll hit add assignment. It'll be faster for you than it is for me, don't worry.
So I just noticed that there are 2 questions, and we're going to keep them until the end of this presentation, and you're going to get an answer to those very soon. About the workflow, you're going to get to see that in what James is showing.
Okay, so we're going to create a new assignment. We can call it, what do I want to call it here? Birthday, and we'll give it a point value of 20. Now, codePost is an end-to-end feedback tool, which means students can submit directly to codePost. 95% of the time, you'll probably want to use codePost for student submission. However, maybe you already have a submission tool which you like. Maybe it's mandated that students submit through your LMS. If that's the case, you can just select no here and then upload student work manually in the manner I'm about to show you, or we have integrations with LMSs that make it easy to do if that's how you're getting student submissions. So I'll go ahead and hit create. Okay, so we added a new course, we created a roster, we've created an assignment. Now we're going to go ahead and upload those submissions for those students for this assignment. So step 4, I've linked here a folder containing 5 submissions corresponding to those 5 students. So you can click that link to download that folder. Once you've done that, hit this gray upload button. And the way this works is we're just looking for a folder that has this structure. So top level folder, subfolders corresponding to the student emails, and then files corresponding to that student submission within the students folder. You can do partners too by comma separating emails in the folder names. All right, so I've got this downloaded. I'm just gonna unzip it and drag it in. So you see I dragged it in. Now it says I've got 5 files uploaded. I'll hit upload. It's going to show me the files I'm about to upload before I upload them. So 5 students, 5 birthday.javas, no errors. Hit upload. And everything worked.
So do you have to extract the zip file first? Because it looked like there was an option to upload a zip file.
Yeah, actually, I don't know why I unzipped it.
When I click on upload zip file, though, it still wants me to select a folder anyway, it might be a little glitch. Maybe
there's a bug there. Oh, I don't know why I clicked that. Okay, so just to orient everyone, we're now we've just gotten to the fun part, step 5. Writing simple tests. Okay, let's keep moving. So to write tests for this assignment, we're going to go over here to the tests tab, see birthday, and hit create. Now we're going to get a little form that's asking us what language our assignment uses. And there's a drop down here corresponding to common languages. We're doing it in Java, so I'll select Java. Building your environment. Your environment built successfully. Okay, now at this point, we usually get a lot of questions of the form, does codePost support language X? The answer is usually yes. So the way codePost works is we create a Docker container for every assignment, and any language that you can put into that Docker container can be used when evaluating student work. So the list I showed just now, those are the standard ones that come out of the box, but you can also specify a Docker file and just throw whatever dependencies you need into the container. All right, so here I am in our test environment for the birthday assignment. Let me orient you. So this up here defines our environment. As I previously said, we are selecting Java here. If you hover over this guy, it will tell you more information about the container that's being used to evaluate the assignment. Down here, this is called the run script. Now you might be wondering, this is Java, we got to compile. How do I do that? That's what the run script is for. So the run script is a piece of code that will just run before any test is evaluated. So in this case, we're going to be using the run script to compile the student's Java code. And this run script is created automatically for you. In most instances, you won't actually need to edit this. It's just available for you to edit if you want to do any kind of pre-processing before the tests are run. Okay, 2 more sections. Helper files. Sorry, go ahead,
James. I just want to mention like a general principle that we have in codePost, which is we try to have a lot of scaffolding, which is if you don't know if you don't have a specific way of wanting to do something, it'll give you a very good standard definition. But we also realize that, in computer science, what's difficult to design these good products is that everybody has a varying degree of expertise. And we want to make sure that if you need to and if you want to, you can open the hood of this car and then just play with the engine. And that's really been our motto for like the whole design of this tool. So here, you would never have to touch the run script, but if you wanted to, and if you had a very specific desire to use it, for instance, because you already have auto-grading scripts that you want to include inside of codePost, it's available for you to do that. Sorry.
It's a very good point. So yeah, this is the default run script, as Jeremy said, and this is a default Java environment. Okay, so we're still setting up our environment for our tests, and we're going to do 2 more things before we start writing tests. So we have this concept of helper files. These are just additional files that you want to make available for your tests. So in our case, I haven't actually described the assignment yet, but we've got a single kind of input file that we want to make available to student code so that we can run the student code on the input file. So that code is 20birthdays.txt. So you can download it by clicking this link and then upload it as a helper file. And then last thing we're going to do before we actually start writing the tests is uploading solution code. This is totally optional. This is an opportunity to upload a reference solution, and it can be really useful when you're writing tests to make sure that your tests pass on the reference solution, either to debug your test or debug your reference solution. So I'll go ahead and upload a reference solution. You can download a reference solution from this document. It's called birthday.java.
I have a question. So these helper files and the solution code, are those only accessible to the administrator or graders, or will students see those files?
Students will never see solution code. Student code will have access to helper files when it's run inside of our container for the purposes of running tests.
So to give you an example, the helper file, you might have them create a program that reads numbers and tells you if they're all different, or tells you how many are different. And so the helper files are different input files that they might have to use to test their code. And you probably would make those available to them outside of the context of the assignment. And they would also be available when they run the auto grader tests in codePost that they submit directly to codePost.
Right. Just saves the step of having the students to upload the input files themselves. Does that make sense? Cool. Okay, so now let me describe the assignment. So you can read more about it by clicking the birthday problem up here. So here's a quick description. So credit to Bob Cedric for this assignment. Basically, this is a little assignment to teach students about the birthday paradox. So what it does is it takes in it's a little program with one main method that takes in a integer and then a file containing a list of integers between 0 and 365. And the program is supposed to essentially output the number of M collisions in the list of birthdays. So running Java birthday 2 on 20birthdays.txt finds that there were 7 birthdays, 7 unique birthdays examined to find, we went through 7 integers to find the first collision, and that collision was 101. Birthday paradox. So to tie this back to what we did, 20birthdays.txt is a list of 20 integers corresponding to birthdays. And this reference implementation just looks through the list of birthdays and tries to find an M collision. So let's go ahead and write some tests for this assignment. So I'll go back to the document and I'll scroll down to step 5. So back in codePost, just gonna make my window a little bigger. I'm gonna select the tests tab. We've been in the environment tabs, laying the groundwork for our tests. Now I'm gonna head over to the tests tab. And you'll see codePost tests are 2-tiered. So first I've got to create a category. I'll just call this correctness. And then I can click this add test button. Okay. So far, so good. So let's create our first test. Let's call it, I don't know, test 1. And there are a few different test types in codePost. We'll walk through first the simplest, which is called an input-output test. And as the name implies, what an input-output test is intended to make easy is running student code on a specific input and asserting a specific output. So in our case, we're going to run from the command line, and we're just going to run what we have here in the document. We're going to run Java birthday 2 on 20birthdays.txt. So I'll just copy that, paste it here. So this is the invocation we're going to run for this test. And when we run it, we want the student code to print a specific string. And that string is going to be this: 7 birthdays examined to find 2 occurrences of 101. So I'll copy that. Go back to codePost and paste that in. You can see here there's some pseudocode. So you can see here that it's just saying I'm going to run Java birthday to 20birthdays.txt, and I'm asserting that the output is going to be equal to the string you've provided. Down here, you see there's something that looks kind of like a terminal, and this is where you're going to run and debug your tests. So you can see here, I've got student solution code selected. I had previously uploaded the solution code. So now if I hit run, it's going to run this test against my solution code. Sometimes the first run can be a little slow. And we passed. So if you've gotten this far, congratulations on writing your first codePost test. But I'll pause just to see if anyone had any issues or has questions. Who was able to get the test to pass? Very nice. Question we sometimes get at this juncture is, well, you know, it's a bit strict to ask the student to output this like really specific string. You know, what if they had capitalized occurrences or spelled something wrong, but actually had gotten the meat of the question, right? We had this option here selected called constant strict. So this is asserting that the student output has to match the string that's been provided exactly. We have another option called flex, which, oh, that's a bug, just ignores white space and capitalization. So if you wanted to be a little less strict, you can use that mode. If you want to be advanced, you know, if a student misspelled birthday in this case, even flex mode would assert, you know, failure in that case. You can use the regex mode to specify a regular expression, and the test will pass so long as the student's output matches that regular expression. Any questions? Okay, so I'll pause here and then go ahead and create 2 more tests using these prompts here.
So James, I guess I have a bunch of assignments that already have JUnit tests. Is it trivial just to upload existing JUnit files, or do you have to like put them into the provided format? Or
common question. Let me send you right now a help document that describes how to run JUnit tests in codePost.
Thanks.
I just shared the document.
Got it, thanks.
Okay. Was everyone able to get those tests set up? Yep. So we've only got 12 minutes left, and there's a lot more to cover. I wonder if folks would like to spend more time on the autograder component of codePost and write more automated tests, or if you'd like to pivot and go through the manual feedback workflow that Jérémie was talking about. Any preference? I prefer the manual feedback workflow. Okay, let's do it. So if you're following along in the document, let me share my screen again. We will skip ahead. Well, why don't I just first give a quick tour of the manual feedback mode. So here in the admin console, I will go down here to the submissions tab and then select by student. Once I've done that, I can select a student's submission here. And here it is. So this is what's called the codePost code console. So this is where the actual work of evaluating student code happens. And this is the same experience regardless of whether you're an admin or a dedicated grader. So it's really simple. The way it works is student code is here. Files are presented here on the left. To make a comment on student code, you just highlight. This is a custom comment. And to the question earlier, you can deduct or add points via custom comment. So these are the basics. We also have dark mode for those who are grading at night or just prefer dark. And then let me introduce you to another primitive, which is the rubric. So over here on the left, you see it says rubric, but there's no rubric defined. So let's head over to the rubric editor to create a rubric. So that's over here, assignments, rubrics, and then hit create. Just like tests, rubrics are two-tiered. So I can create a category. I could call it, correctness, and I could say a comment inside the correctness category is maybe like an off by one error. As Jérémie was saying, deductions can be associated with rubric comments. So I'll give this deduction a value of 1, and then I'll save. So we've just created our first rubric. If I head back to the submission, here's the rubric we just created. To apply this rubric comment, I can highlight and then click. And so you can see here what that looks like. So here is this quote here represents the rubric comment, and this text box allows you to add that personalization that Jérémie was talking about. So, for example, here you could point out the how the student's code could be corrected, for example, and you can use Markdown here as well. Any questions about the code console or manual feedback? I'm curious how this compares to tools that you all use today.
I love the plus and minus button that increments by half a point. That is so slick. I don't know why little things like that make me happy. And the dark mode is nice.
I have a quick question. So, and here that you have a rubric item, and then that is it possible to say that the students may make the same mistake and more than once? And I only want to deduct the points once, but I also want to point out the other locations that he made the same mistake. How can that be done? Is you've add and customize and the comment, or you can, and again, drag that a rubric item, but without cutting points?
We don't yet have an option to say only deduct once for comment, but that's a really great idea. The way that we've been doing it is to have categories that have caps. So that's the point limits. And so the way that it would be used is say, for instance, that you are grading the submission on style, and the student is misnaming every variable in their code. Well, maybe you want to deduct half a point for that, and overall in style, you don't want to deduct more than 1 point. And so you would create a style category and create a point limit on that category to whatever you would want. So that's how we've been sort of using a grand way of making sure that there's not too much overlap between the deductions without having to go into the detail of whether some deductions can be applied multiple times or just once. But I think that what you just said is really great feature idea that we'll consider adding. Because
that actually helps. And I actually, in my mind, I'm saying can you have a category? So just for that one item by itself.
Yes.
And then saying that it's just the limit of points, but then now you can end up. Okay.
Precisely.
Okay.
Yes.
Okay.
And let's just,
thanks.
It's a bit hidden. Mm-hmm. So we try to make, in general, another principle we try to adhere to is keep the experience for new users simple and only add complexity when it's warranted. So in the rubric, you'll find a bunch of settings. If you open up the rubric editor, hit settings.
There's a settings.
You'll have to open that and then hit show point limits. Once you do that, you'll see this category point limit thing appear. And then let's see how it works. So here's the rubric item. I just renamed it according to the example Jérémie was giving. So we've applied it once. I'll delete this comment. So you see the student's grade is now 19.5 out of 20. I'll apply this comment again. 19 out of 20. I'll apply it again. Still 19 out of 20. And that's because the cap is 1.
Thank you. That's very helpful.
If you click here, you'll see that the breakdown explained. Any other questions about manual feedback?
Are all the rubrics essentially point deductions or additions, or is there a way to have a 2-dimensional rubric where a category could be one of, like a 1, 3, or a 5, for example?
No, yeah, it's totally possible to mix and match. I'm guessing, do you grade additively? Do you start from 0 and add points?
I usually do, yeah.
Yeah.
But it depends on what mood I'm in, I guess.
Yeah, so we have a solution for you.
Yeah, so many settings. Wow.
That's all software is.
Yeah.
Just settings. So yeah,
I mean, sometimes people come from a world like the Canvas speed grader, where they think of rubrics as like a table, right? Where there's rows and columns, but then they move into a tool like this or a tool like Gradescope, where there's like items that you toggle on or off. Is there a way to like do both, I guess?
Jérémie, do you have any perspective there?
Well, what you see is what you get, which is that essentially what we've showed you around is the functionality that's available in codePost. But like you know, I have very specific ways of wanting to do things. And an example of that is the auditing checkbox system that you saw. Mm-hmm. That comes into this last part of this workshop, which is that codePost, it was built with an API first approach, which means that essentially the product is two things. There's the API and then there's the UI that we built on top of it. So everything that you can do on the website, you can also do with the API. And so we felt that rather than anticipate all the different ways that, you know, people do their own thing and have their own great ideas, we would try to make sure that anything you can do with a mouse and a click, you can write a script to do as well. And of course, that doesn't mean that you can do anything on your own, but it means that if you have like maybe, so this term, I have a talented student that is working with me, he's my assistant, and he's helping me build a lot of functionality that I want to use that isn't yet in the product using this API. So to answer your question, the sky's the limit really with what you want to build with this API. We haven't shown you webhooks, we haven't shown you the SDK, but it really is very powerful.
There is a setting that somewhat approximates what you're talking about, which is this at most once toggle setting. So
that makes things mutually exclusive that way?
Exactly, exactly. So you'd have a category, you know, it would be, I don't know, correctness score, bad, okay, good, 0, 2, 5, for example, with additive scoring.
Hi everyone, it's actually 5:30 right now, so perhaps we need to close this, and perhaps we have more questions, we can just send you emails, right? Yeah,
that sounds great.
Okay, actually I have a quick question for you. How much is this? I mean, to use.
Oh, how much does it cost?
Yeah.
It's free. We charge for consulting.
Oh, that's very nice. All right, that's good to know. Yeah. All right.
Really? Now that's because I was looking at this and thinking, okay, well, this is very nice, but you know, they haven't mentioned anything, and yeah, they're going to save that for the end. It's like there was a product I'm not going to name. It's like it was free when I was using it a while back. I haven't used it in a few semesters. Well, they've since moved to we are now a paid model, and we're proud of our product. It's like it's no longer worth it, at least for me. But okay, so this is your charge for consulting. This is free to use. Okay,
that's right. We charge. You can see in our pricing. If you go to here, I can share quickly.
Okay.
I know we're at time, but this is an important topic. So yeah, this is the pricing. So everything I've showed you is in this free tier.
Now, what's your cutoff as far as large departments?
So the free tier includes unlimited students, unlimited assignments, unlimited everything. Large, this is just to indicate that large departments are probably ones that might want to pay for live chat or custom system integration. Because,
well, you're aware we've had a bit of a pandemic going on the last year or so, and for state universities, at least for us, I mean, it's going in and talking to the dean about I need money for anything is just, it's almost a non-starter. Yeah.
Hopefully this makes that conversation a bit easier.
Yeah. I mean, it's, it's not good for anybody right now, but okay.
Yeah, let's thank the speaker. Great. Yeah, let's give him a big round of applause. That's wonderful. Yeah.
And
thanks for having us.
Thank you so much for inviting us. We're very excited to be able to present this to all of you.
Okay, and now I know that you were recorded. Kendall's been out in the main room, but he was expressing some interest in this, so he might be contacting you, asking if he can take a look at the recording.
Excellent.
And if that's going to be online somewhere, we'd definitely be interested in that.
Okay, excellent. And for all of you who started using codePost today, please don't hesitate to reach out to us. If you want to test it out, we would be more than happy to support you directly. And if you have any questions or any feature requests, please don't hesitate to let me know. It was really nice to work with you today.
Okay.
Yeah, thank you very much.
See you all.
Thank you.
Bye.
Appreciate it.
Bye.
Thank you.
Yeah.